The Copenhagen Interpretation. The Copenhagen Interpretation is one of the most widely discussed and accepted explanations of quantum mechanics. Quantum mechanics is a branch of physics that deals with the smallest particles in the universe, things like electrons, photons, and atoms. The Copenhagen Interpretation was developed in the 1920s by physicists Niels Bohr and Werner Heisenberg, two key figures in quantum theory. This interpretation addresses the strange behavior of particles at the quantum level, where the usual rules of classical physics don't seem to apply. To understand the Copenhagen Interpretation, it's important to first grasp the core concept of quantum mechanics: superposition. In quantum mechanics, particles can exist in multiple states at the same time. For example, an electron can be in two places at once, or a photon, a particle of light, can act like both a particle and a wave at the same time. These particles exist in a state of uncertainty, where their exact position or state isn't determined until they are observed or measured. This is very different from the everyday world, where objects have clear, defined positions and behaviors. The Copenhagen Interpretation states that quantum particles do not have a definite state until they are observed. In other words, before measurement, particles exist in a cloud of probabilities where all potential outcomes are possible. But as soon as we observe or measure the particle, it collapses into one specific state. This is called the collapse of the wave function. To make this clearer, let's use a well-known thought experiment called Schrödinger's cat. In this scenario, a cat is placed in a sealed box with a radioactive atom, a Geiger counter, a vial of poison, and a hammer. The atom has a 50-50 chance of decaying, which would trigger the Geiger counter, causing the hammer to break the vial and release the poison, killing the cat. According to quantum mechanics, until the box is opened and the cat is observed, the cat is both alive and dead at the same time, because the state of the atom is in a superposition. Once the box is opened and the cat is observed, it collapses into either a state where it's alive or dead. This is where the Copenhagen Interpretation comes in. It tells us that the cat is neither alive nor dead until someone opens the box and observes it. Until that point, the cat's state is undecided. The act of observation forces nature to choose one